Welcome back to our channel. In this P3 Maths series, we are talking about the binomial expansion. Previously, in the partial fraction past paper questions from 2023 video, we did some questions from year 2023. From those questions, what kind of questions we get? Let us show you what kind of questions we get. So in the first part, a question will ask you to express a rational expression into partial fractions. And then in the B part, they would ask you to obtain the expansion of those partial fractions up till some power of x. It could be x squared, it could be x cubed. And in the C part, they would ask you to state the set of values for which this particular expansion that we have done. Now the partial fraction, the binomial expansion, will be valid. So since we already expanded this in the partial fractions video, we can just carry it on from right over here. So we expanded it 4 over 1 minus 2x plus 2 over 1 plus 2 plus x and 7 2 plus x whole squared. Now so in this question we are expanding 3 expressions now, and then we're adding them up. So this, you have to be very careful with what we are doing. So when we have 4 times by 1 minus 2x, as you can see there's 1, so we don't need to factorize anything. So 4, we can just jump into the expansion. So 1 plus -1 times by -2x plus -1 -2 2 factorial -2x whole squared. And since we just need up to x squared, so we can just leave it over here. So 4 1 plus 2x minus 1 times by minus 2, that is 2. 2 factorial is the same, so it can cancel. And then minus 2x whole squared will be just plus 4x squared. So when we multiply the 4 inside, we have 4 plus 8x plus 16x squared. Then we have the 2 over 2 plus x. So first off, we need to see what 2 plus x is. We need to factorize this. So since this is not a 1, we need to expand it from 1 plus or minus something. So we factorize out the 2, and this will become, this will become 1 plus x over 2 raised to the power minus 1. So 2 raised to the power minus 1 is just 2, 1 over 2, sorry. 1 plus x over 2 minus 1. And then when we multiply this 2 with it, this would just simply cancel out and make it into 1. So we don't need to worry about the 2 over here. So we expand just to simply 1 over 1 plus x over 2. 1 plus -1 times by x over 2 plus -1 -2 2 factorial x over 2 whole squared, and that's our expansion. So let's simplify. 1 minus x over 2. Again, minus 1 minus 2 is 2. 2 factorial is the same. And then we have x squared over 4. Continue. Similarly, we have 2 plus x whole squared. So 2 plus x whole squared will be handled same way. So 2 raised to the power minus 2 comes out, and 2 plus x, this will become 1 plus x over 2 minus 2. And then we have a 7 multiplied also. So 7, when it's multiplied, this will become 7. 2 raised to the power minus 2 is just 4. So we will have 1 plus x over 2 raised to the power minus 2. Now let's expand it. 7 over 4 is kept outside. we will have 1 plus -2 because power is now -2, x over 2 plus -2, -3 over 2 factorial, x over 2 squared, and then we simplify this a bit better. So 2 and 2 cancelled, and this 2 factorial cancels out with 2 over here, not a negative. So 1 minus x over 2, then minus minus becomes 3 plus 3x squared over 4. And when we multiply the 7 over 4 inside, we will have 7 over 4 minus 7 over 8x plus 21 over 16x squared. Now, let's collect all the expansions into one simple form. We had 4 over 1 minus 2x plus 2 over 1, 2 plus x, and minus 7, 2 plus x whole squared. So this will be expanded into, let's write the terms vertically so it will be easier to sum them up. So 4 plus 8x plus 16x squared. Then since it was plus 2 over 2 plus x, so that is going to be plus 1 minus x over 2 plus x squared over 4. And then this time for the third one, it is subtracted. So we have the signs reversed. So minus 7 over 4 minus plus 7 over 8x minus 21x squared over 16. Now let's calculate them. 4 plus 1, 5, minus 7 divided by 4, 13 over 4. Then we have 8 minus 1 divided by 2 plus 7 divided by 8, 67 over 8. Sorry, my bad. I think I made a mistake somewhere over here. Sorry, my bad. Over here, we did not have to write the 2 over here. I mistakenly wrote it. So this is just 4. This is just 1. And this would be 4. So 7 over 4x. Sorry. So 7 over 4 instead. And that would be 37 over 4. So plus 37 over 4x. And then we have these three terms, 16 plus 1 divided by 4 minus 21 divided by 16, 239 over 16x squared. And that's our final expansion. C part would be, we have to tell the range of values of x. So for 1 minus 2x, 2x mod would be less than 1. And for 2 plus x, that would be the same. So that would be mod of x less than 2, or 1 minus, 1, that could be rewritten as x over 2 mod less than 1, which both ways are the same, but we will, let's take the intersection. So for the left one, this would simplify to less than 1 over 2, and this one is basically, we can keep it as mod of x less than 2. So the intersection would just simply be mod of x less than 1 over 2. Right. So that's the full question. Now, moving on to the October, November 2023. Variant 33, question number 9. This was part A partial fractions. Now we're going to do the part B and the C. So in this question, we have to go up till x cubed. So the B and C part are the same. Send obtain the expansion up till the x cubed terms, and we need to give this range of values of x for the where expansion is valid in the exact form. So okay, all right. So going back to the expanded form that we found out. So 5 over 2 minus x. So as before in the previous question, so 2 minus x will be factorized. 2 minus 1, 1 minus x over 2 minus 1. So 2 raised by minus 1 is just 1 over 2. And then 5 multiplied would be 5 over 2. 1 minus x over 2 minus 1. So now let's expand this. 5 over 2 multiplied by 1 plus negative 1 times by negative x over 2 plus negative 1, negative 2, 2 factorial, negative x over 2 whole squared. Since we need to get up to the x cubed term, so we need to include that. Negative 1, negative 2, negative 3, 3 factorial, and then we have negative x over 2 whole cubed. So let's simplify this first. So 5 over 2, 1, this would become plus x over 2. This would just get cancelled. This would end up, the third term would end up to be x squared over 4. And 3 factorial, the 3 times by 2 would cancel out, but the minus sign will remain. However, the cubed minus x over 2 will also have a negative sign, so minus minus will become plus again. So we will have x cubed over 8. And then when we multiply the 5 over 2 inside, we will have 5 over 2 plus 5x over 4 plus 5x squared over 8 plus 5x cubed over 16, and that's it. Now, let's expand through 2 plus 3x squared. Now, this is going to be complicated because at the end we have to multiply the 3 minus 2x also. So first, let's expand the 2 plus 3x squared first, and then we will multiply that. So 2 plus 3x squared, 2 will come out, minus 1. We will be left with 1 plus 3 over 2x squared minus 1. So this is just 1 over 2, 1 plus 3 over 2x squared raised to power minus 1. So let's expand this. So 1 over 2. We have 1 plus negative 1. 3 over 2x squared will come as it is. Then plus negative 1, negative 2, 2 factorial. Now notice one thing. So when we have 3 over 2x squared whole squared, this thing will turn to power 4. So we don't need to include that because we are only asked to go up to x cubed. So we will erase that. So we don't need this. So we will stop right over here. So this will go up till 1 over 2, 1 minus 3 over 2 x squared. And then when we multiply the 1 over 2 inside, that will be 1 over 2 minus 3 by 4 x squared. This. Now let's multiply the 3 minus 2x. 3 minus 2x multiplied by 2 plus 3x squared minus 1 approximates to 3 times by 1 over 2 minus 3 over 4 x squared and minus 2x times by 1 over 2 minus 3 by 4 x squared continued. Sorry. So this would become 3 by 2 minus 9 over 4 x squared. Then we have minus x, because 2 divided by 2, plus 9 over 4. No, sorry, 6 over 4 x cubed. So that's the expansion. So if we want to write it in the ascending power, so 3 over 2 minus x minus 9 over 4x squared. 6 over 4 is just 3 over 2. So 3 over 2 x cubed. Right, okay. Now we need to add them together, add the expansions together. 5 over 2 minus x plus 3 minus 2x over 2 plus 3x squared. So the first one was this thing. Let's copy this as it is. And then for the second one, since it is plus in the middle, so we will add up 3 by plus 3 by 2 minus x minus 9 over 4 x squared and plus 3 by 2 x cubed. So now the final answer would look like 2.5 and 1.54. The next one is 5 divided by 4 minus x, which is one coefficient, 1 over 4, so plus 1 over 4 x. Then we have 5 divided by 8 minus 9 divided by 4 minus 13 over 8 x squared. And then we have 5 divided by 16 plus 3 divided by 2. We get 29 over 16x cubed. All right, and that's your expansion. Now, for the C part, where we have to state the regions for range of values of x for which this expansion is valid, we just need to look at these things. So the first one would mean that mod of x should be less than 2, and that should intersect, or we need to find an intersecting overlapping region with mod 3x squared less than 2. So this one is already simplified. We just need to work on the second one. So 3 goes on the other side. And when we take the square root, it simply becomes square root of 2 over 3. And when we consider that we are taking the intersection or overlapping region with x mod less than 2, this would be the intersecting part. So the final answer would be mod of x less than root 2 over 3. And that's our final answer in the exact form. On to the next question. Now the next one is May, June 31. So let's see the May, June 31. Part A we have done. Part B is the integration. So that's not the binomial expansion one. So the next one, let's see, that was 32 that we did. Okay, so let's see the 32. So 32 works in partial fractions, and then that's also integration, so not the binomial expansion question. The next one was May, June. We skipped that one. because it was a same repeated factors case. Okay. Now on to the February-March 2023 32. Let's see that one. So express f of x in partial fractions, and that's also the integration question. Okay, since we are done with the 2023 papers, so we can move on with the next topic. See you in the next video. We'll start off with exponential logarithmic equations. Bye bye. Take care.